Hello and welcome to another Polyworks webinar. As it's Valentine's Day, we here at 3D Scanners thought it would be a great time to show you the power of Polyworks Modeler to mend a broken heart. So let's begin today's webinar. So as I mentioned, we're going to start to look into Modeler and how to repair our broken heart. So we're going to look at techniques such as hole filling and improving the structure of our STLs in order to do that. If you do have any questions regarding the webinar as I'm going through, please see the live chat where one of our operators will be happy to answer any of the questions that you may have. So let's get started. So I'm going to open up Polyworks Modeler. So using this icon here. Just wait for that to open and then expand. What I'm going to look to do first is we need an STL, we need to find our broken heart. So if we click on the import icon, and then we can use the import polygonal model, which is this icon here. Import our broken heart, and then confirm the units, so we hit OK. So this will now hopefully bring in our broken heart, which we will now look to begin to repair. So in order to begin to select some of the data, so you'll see that we have a few cracks, or a couple of cracks, and a few different holes and pins on the back that we need to remove and look to begin to repair. So if you're not aware, in Polyworks you have the Select Elements tool, which allows you to begin to select certain parts of the STL. So that is also the spacebar as well. So if I hit the spacebar, you'll see that jumps in and out of that particular tool. What I'm going to do first, though, before I do that, is I'm going to square it up a little bit just to make this a little bit easier using our coordinate system. So hitting the spacebar, again, allows me to jump into the Select Elements tool. Now, in Polyworks, you do have a few different techniques on selection, so I'm going to run through a couple of those with you now. First of all, when you first go into the Select Elements tool, you are on the Multiple Selection tool, which, as you can see, as you hover over, it gives you the shortcuts and the quick access keys on there. So what I can do to begin with is the circle that's around the crosshead can be increased or decreased using the scroller on your mouse, and a manual input can be typed in there as well. So what I'm going to do is hover over the center of this circle and left mouse click, and then what I can do to remove that is hit the delete key. If I hit space to come out of Select Elements and then zoom in, you'll see that has removed the hole for us, or it's removed the pin, but it has left a small surface there. So what I can actually do is, because that is an island by the looks of it, what I can do is I can hit the spacebar. On the main body of the STL on our heart, what I can do is I can right click and go to select triangles, and then I can click on island. So as you can see, that will select all of the main body of the heart for me. And then what I can do is go back to our dialog zone and click on the invert button. So as you can see, that's inverted the selection. At this point, I can hit delete, and that will remove that for us. Now, as you can see, based on the selection parameters that I've used, that has also got rid of a hole or some surface on the other side of our STL. So just be careful with that. It is fairly simple to repair, as I will show you shortly. Just bear that in mind for future use. Looking at this one here, so what I could potentially do is, if I hit the spacebar, I could use this particular tool here, which is the Selectable Faces, currently set to front and back. If I set that to just front and make this diameter a little bit bigger, so if I do this here, so if I left mouse click, you will see that only selects the positive faces. Now, the only issue with that, as you can see, is it hasn't quite selected all of that bit there. So what I'm going to do instead is, jumping back into Select Elements, I'm going to change our selection type from surface to volumetric, and I'm also going to set that back to front and back. So if I left mouse click now, you will see that goes all the way through and also selects all of the side wall of our pin that's there. So I can hit delete, and that will remove that particular part of the STL. So just to do the same thing to finish off, look at it sort of normal too, hit the spacebar, decrease my size of selection, and because I'm already set to that, so there are shortcut keys you can do that with. If I left mouse click and hit delete, so that will remove that hole for us. If I look to begin to remove the cracks, what I can do is, again, hit the spacebar to go into Select Elements, I can change my selection tool to this one here, which is polygonal contour. And what this will allow me to do is if I left mouse click, that will allow me to draw a polygon around that particular crack. And then once I get to the end, I can right click, and as you'll see, that will do that there for me. Now at this point, I could delete, or I could just continue on the other side over here and do the same for our second one. So what I can then do is again, select all of the crack sort of around the outside and right mouse click to confirm. If I then hit delete, you'll see that has removed the side walls of that crack for us. So now that is a lot easier for us to repair. So at this particular point here, we're going to look to begin to actually repair this. So we've had to do a little bit more breaking of the heart to start with, just to make it easier for us to begin to repair. So what we're going to look to do is jump into the polygon icon, and there's a few different tools in here which we will begin to use to repair our heart. I'm not going to use these two today at the top, but for example, you could, if you have a sort of rough surface you would like to smooth, you have the Smooth Vertices tool, and you can also do this manually using the Reconstruct Mesh. So that would involve sort of jumping into your select elements and selecting a certain area, and then you can use the hammer tool to smooth a particular area of the STL. What I'm going to look at to start with is closing off our sort of 6 sort of circular holes that we need to close up. So you could do this by using the automatic hole filling, which all you do is you insert a maximum distance, and what that will do is it will look to find any holes smaller than that value that's inside that input box there. So I'm not going to use that one today either. I'm going to use, in the polygon tool, this one here, which is called interactive hole filling, just to go through with you a couple of different techniques and how you can close varying holes. So you'll see we've got many different icons and radio buttons to select. So to start with, I'm going to use the operation which is called fill, and the method is called single boundary hole. And what you do is you hover over a particular boundary. As you'll see, when I hover over it, it turns to blue. I can then left mouse click, and that will close that hole up for us. Now, what I could potentially do is clean it first. So what clean will do is if I use this one here, which is single boundary hole, what it will do is it will remove a layer of the hole first. So the hole and the STL, sorry, are made up of lots of different triangles, which you will be able to see in a second. I can choose the number of elements, or sorry, the number of layers that are removed when I click. So if I set that to 2, for example, if I hover over the boundary, so if I use this one here so I can see which one it is I'm using, left mouse click, and you will see that that begins to actually increase the size of the hole. So that looks to clean up the edge to start with to aid the closing. So what I can then do is also use the one which is called clean and fill, and that will do both there. So again, you can see I've got the number of element layers. So what I can do is do this one here. So it will clean away 2 layers of triangles, and then it will close up. So you'll see that in front of you now. And then as you can see, I do have some holes on the back, so they are visible through the STL. But if I just clean and fill this one too, and then what I can do is if I need to spin my heart round or spin my STL round, I can use this icon here, which is our 3D scene manipulation. Spin that round, and what I can do is exit from that, and then what I can do is go to fill, and we have this icon here in our method, which is for multiple boundary holes. So for our 3 here, I can left mouse click to select each one, and then right click to fill those. So as you can see, that's done a nice job of filling those for us. I will jump back into this tool shortly to continue to repair our broken heart. So if I close that for the time being. One technique that we would recommend, or I would recommend personally to do for this, is to change the display of your STL to aid the next steps we're going to do. One step you could do for this, for example, is if you jump into your object display options, you can change the color mode from material color to curvature. So what that will do, look, is it'll actually show you where the rads are. So this will enable you to choose the right tool relative to the type of surface that you're looking to close up. That is one particular method you could use. I'm personally not going to use that one today. I will show you one that I prefer. So if I set that back to material color, what I can do is I can display the triangles that make up this model. So I can do that by right clicking on the STL in our tree view, and I can go to view, static, and then flat and wireframe. So you'll see if I zoom in, it will now show you all of the triangles that make up this model. So if I highlight a particular area, you'll see that on the radiuses, we have more triangles than the flat surfaces, as this enables the curvature of that fillet, as we can see there. What I can look to do is I can look to reduce the amount of triangles that are on this particular part here, because it's a flat surface, we don't need that many. So what I can do is, again, jump back into my polygon tool. And I can use this tool here, which is called Reduce Triangles. Now, you've got two different methods for this. You have tolerance, which the way that this works, it's the maximum distance between the polygonal model surface after the triangle reduction relative to the initial surface. So if, for example, I change this value to 0.001, that's only going to potentially move the surface by 1 micron in order to reduce the triangle. So very limited movement. The alternative is the number of triangles. That is a percentage of the triangles you wish to keep. So if I leave that to tolerance, that will swap back as you've just seen. So if I hit reduce, so that will now look to reduce the amount of triangles. So you'll see not by too many, but you'll see. If you do wish to know how many have been reduced, you can double click on your STL, and then in your model tab, it will tell you in here the number of triangles that make up that particular STL. What we can do here at this point is you will see that if I zoom in, the triangles are all different types of triangles. So we have a few equilateral, we have a few isosceles, and we have a few different right angle triangles as well. So for example, we have a right angle one there. What I can do is I can look to improve the sort of the spread of those triangles and try and make them as equal as possible. So I can use the polygon toolbar again and jump into this icon here, which is the improve equiangularity. So what I can do is hit apply. And this tool looks at improving the equiangularity of the selected polygonal model, the triangles within the model, while also preserving the shape of the model and minimizing the number of added triangles. So that will look to spread the triangles across the part nice and sort of spread the differing types across the model. So just wait for that to finish up as it's doing now. And you'll see if I zoom in, you've got a much sort of more even spread. So they are much more equal than they were before. So I can close that. This will have now aided the ability for us to close the cracks, because you'll now see that we have a definitive split where the radius was relative to the actual flat surface on that crack. So what I can do is jump back into our polygon toolbar, and I can jump back into our interactive hole filling. Within the fill operation, we now have a few different options relative to clean and fill. So if I leave that on fill, you'll see we have a few different options. So to begin to remove the sort of flat part of the crack on the surface, I can use this particular tool here, which is the partial hole filling. Leave that on curvature based. You can leave it on, you can change it to flat, but it won't give you the amount of triangles. So if I give you an example, what I can do is zoom in, so I can either hit the manipulation button or press the space bar. What I can do is just away from the radius, I can look to fill that. But as you'll see, it doesn't sort of match the triangles that already exist on that surface. So I'm just going to undo that and show you the difference between flat and curvature based. So if I left mouse click on this part here, and then a vertice on the corresponding side, left mouse click where the blue sort of boundary is, and that will fill that particular area. So you'll see that that's filled that nicely for us. So if I hit close, you'll see if I spin that around, you can see that's nice and smooth on that particular face there. So if I repeat the same process on the other side, jump back into our interactive hole filling and just zoom in so I can see closer where that rad is. So roughly here, for example, and then the same on the other side. And again, where the blue boundary is, that's where it's going to be filled. So yeah, again, that looks quite nice, so I can rotate that round. So in dynamic mode, we are on the normal sort of visual of the STL. So there's two different techniques I'm going to show you for filling the rad at the top. So I'm going to start off with the first one. So I will do the same first off on both. So I'll look to use the gap filling tool. And what I'll do is I'll look to do the straight edge here. So if I just do that again, so if I hit close, I'll just jump back in there, just picked a rogue point. So I can, roughly where the flat starts to go into rad, I can choose a point on one side and a point on the other just before we get to the rad. So what that will do is it's now selected that particular part of the boundary, and then I can then bridge across. So I can rotate this round again to this particular side, just away from the rad, so sort of there will do, and then sort of similar on the other side. So that will look to bridge the top. So if I rotate that round, you can see that's done a nice job of closing that particular gap. The two different techniques are now these two bottom icons here. So we have cylindrical gap filling, which you will see I can select the point on that side there. So make sure I'm not in manipulation mode. I can select a point on the rad there and then just there. So just away from the flat, and then the same on the other side. So again, it's similar to your gap filling tool in the way that it works. And what this will look to do is it will just look to close where I've selected. The alternative is the other tool, which will look to close the entire hole. So if I just repeat that on the other side, so you can see again, similar to our gap filling tool, I can select a point just away from the rad on both sides and then link that across to the corresponding boundary on the other side. Just wait for that to finish its operation. Again, you see that doesn't look too bad. So what I can now do is our 4 holes, I can flick back to the multiple boundary hole and then just close those off. So I can do this by left mouse clicking. That will highlight those in red. I can rotate, and then once I've selected all of those holes, I can right click and that will fill those for us. So again, you can see the clear distinction between where I filled some of those holes relative to the original STL. So if I hit close, I'm just going to zoom out to see how well that's done. So that doesn't look too bad. And then I will do the same on this particular side over here. So we will look to do the same again. So I will jump into interactive hole filling and I will quickly just sort of straighten that edge off. So just before the rad, so again, if I just click over here and do that again, so where that straight is, and then the same on this side here. So just below the rad, and then close the blue area of the boundary. Same on the other side, so again, just making sure you stay away from the rad, not too close, and then the same on the other side, so a little bit further away that side. And as I said, we're now going to look at the final icon in your interactive hole filling, which is the fillet and surrounding. So this will do the same job as before, except it will close the entire hole. Having said that, I still need to look at my gap filling first. So same as before. So just make sure I'm in my manipulation mode so I can rotate. And then again, where the boundary begins to flatten, I can just do that just before we get to the rad. Same on the other side. So just away from the rad ever so slightly. So again, that's worked nicely. And then just to finish off this bit, we can go to fillet and surrounding areas. And it's the same technique as before. You select just above the flat, so just sort of roughly there, and then just where the rad starts to go away. And then the same on the other side. So just a little way away from the gap, and then the same on the top here too. What this will do, different to the other one, is that instead of having the gap, this should hopefully fill the hole there, which you can see. So again, if I zoom out, that's done quite a nice job of closing that for us. And then I will now do the same on the other side. So jump back in, so just away from the edge a little bit, same on the bottom, and then the same down here as well. So again, that will look, so just out of view, but that will look to close that hole off for us. Once that hole has been filled, you will now see a display message that pops up to say that all of the holes have been in the displayed model have been filled. So we now have a watertight STL. So what I can do is if I close that down and zoom out, before we export this or take it into Inspector or whatever we need to do with it, we can look to again improve the sort of split of the triangles. So I can look to reduce those if I wish. So I can jump back into my polygons icon and go to reduce triangles. Only this time I will change that to, for example, 0.05 and hit reduce. So this will decrease the amount of triangles on the flat surfaces. You don't want to put a number in there too high, as it will start to begin to affect the curvature of the part. So that's done quite a nice job. You can see where we have our fillets, we can still see that we have a high enough amount of triangles to be able to continue the curvature. And then on the flat surface, we don't have too many as it's not needed. So at this point here, we now have an ordered and cleaned STL. So what I can do is close that down. I can look to save our modeler project. So if I hit save as, save that. And now as it's Valentine's Day, we can look to improve the way that that heart looks. So what I can do is I can right click on the broken heart STL and I can then transfer that to Polyworks Inspector. So that will now look to open up Inspector and put that in there for us. So for other purposes, you could use this for inspection. You could look at some inspection tools. But seeing as it's Valentine's Day, I will jump into the properties of the STL and change the color there so it's more seasonal. Thank you for watching today's webinar. If you have any ideas about future webinars, please let us know either in the live chat or contact us on any of our social media channels. Please feel free to contact us directly at support@3dscanners.co.uk, where you can find further support information and any other services that we may offer. Lastly, I would like to say from everyone here at 3D Scanners, happy Valentine's Day and thank you again for watching. Goodbye.